Thank you. Thank you everyone for making all the time to attend this presentation. It's 12 p.m. here in Sydney. I'm guessing it's around 7 p.m. On a Wednesday. It's Thursday over here, so time difference. Amazing how the world works. My presentation is going to be around Pygenitor. Give me a minute, let me share my screen. It's going to be about, let me know if you can see my screen.
Oh, yeah, we can see it just fine.
Sweet. So it's about Pandas and Pyjanitor. The summary of this is make your functions as understandable as possible. If your processing is going to involve lots of repetitions, try and encapsulate them into functions and make your functions things that when you stare at them 6 months, a year, or maybe 2 minutes from now, it will make sense to you. You won't ask yourself, who wrote this? Why did I write this? What does it mean? That's the summary of this entire presentation. So they outlined a bit about me, what is Pygenitor, why Pygenitor, examples, a peek at some functions, and a clarion call. So a bit about me, my name is Samuel, as introduced already, Samuel Oranyeli. Originally, I'm Nigerian, so I moved to Sydney about 5 years ago. Somebody told me Sydney is a wonderful place to be, and I just jumped without even thinking twice, and I'm glad I didn't think about it. I am a core dev on Pygenitor and data table. They are parts, if you're familiar with the R language, these are parts of the libraries in R, so janitor and data table. I like open source. I love open source. I've benefited from open source, so I'm gaining from it as well. I'm a senior engineer at Slalom Australia. This is the jumper. I love the company. If I didn't love the company, I would say it. There's no point selling the company when you're just an employee. But I love it. They gave me the opportunity to challenge myself, push myself, be myself. They also gave me the opportunity to interact with folks. You don't feel that's politicking. There's always going to be politics, make no bones about it, but you don't feel that politicking bearing into your job. You have fun in the job, you write code, you're happy you write code, you chill back on a Friday, you have interaction with your friends. It's great to have it as a second home, away from your family, because this is where we spend most of our time on the job. So yeah, it's a wonderful company. It's based in the US, originally based in the US with offices in Canada, in Australia, in the UK. So please reach out, go to the website. It's a good company. Again, it's a good company. So if you feel you want to be challenged, if you feel you want to be in a place where you're appreciated, check Slalom out. What else? I'm a blogger. I've already had my banter with Andrew about football, and I'm also a tennis fan. I'm also going to cause issues here by saying I'm a Djokovic fan as well. All right, Pygenitor. Pygenitor is basically a data cleaning tool. The whole idea is it's based on Pandas, wrap some functions that are used repetitively into simple, easy to understand names. So verb-like words, so that when you use them, you can say, oh, this is what you mean, this is what it does, and then you can move on. The whole idea is try and spend less time thinking about a problem and just solve it. Think of it the same way we used to have a floppy disks, if any of us remember as a floppy disk back in the day. Nowadays, we just take the flash drive, just plug it in. We don't care about the nitty-gritty or the details. We plug it in, and 99% of the time, we'll believe it will work. It is that 1% of the time that we hope never comes, but 99% of the time is what we're focused on. And that is what Pygenitor intends to do. Wrap those functions that are involved in data cleaning and make them easy for us to use. The focus is on user friendliness. The focus is also on reading is like a chain. So Jake went to this, it went to that, blah, blah, blah. But make no bones about it, performance is also a key factor. But the first part is it understandable? Then we focus on performance. Yeah, so data, we all know data is wild and messy, garbage in, garbage out. If you want good results, if you want your dashboard to be awesome, if you want your machine learning to be great, you need to give it good data. And you can't run away from the fact that you need to clean the data effectively. If you think about it from a sports perspective, Usain Bolt probably spends, I think Usain Bolt as the premier athlete, he spends forever training only to run a race in 9.97 seconds, I think, or 9.77 seconds. So he spent years honing himself just to get to that point. It's the same way with something good. It takes a while for you to get there. And that is what data cleaning is. It's the part that people run away from. It's the part that you cannot do without if you need to deliver. I work as a data engineer and I spend a lot of time cleaning data, transforming data. It's fun sometimes, it is tiring more often than not. So having tools that can help you do the job and just walk away is welcome. Basic parts is every column is a variable, every row is an observation, every cell is a single value. That is the basis of a tidy data or data that is not messy. This is from Hadley in the R world. So once you have this at the back of your mind, you can proceed and do your data wrangling. So let's import our libraries. This is a version, and then let's jump into it. At the moment, all we just need is Pandas, Pyjanitor, and NumPy. I also must mention, the way the Pyjanitor functions are done in the library, you might not even care about Pyjanitor. You just want the function, a particular function. Maybe you want pivot longer because of the way you want to transform something from wide to long. Just go in there, copy that file, and run with it. Ignore Pygenitor. You don't need to install Pygenitor. You just need to take that in. Andrew, you have a question?
Yeah, just before you go on past the definition of what dirty data is, that refers to the structure of the data. So you could be essentially unstructured data is messy data. But what about the values of data, even if it's already well structured? The reason I ask is that in finance, clean data in terms of the values is so important that there are full-time jobs occupied by people doing nothing but ensuring the purity of the data before it's used in financial models. And so when you talk about messy data, are you going to deal with that problem, or is it just the structure that you're interested in?
Well, for that aspect you mentioned, you need the subject matter experts to handle that. You can't just give it to a run-of-the-mill fellow like me who has no idea about finance to determine the purity of that data. So this is just focused on structure. Okay. For that other part of metadata, you definitely need an SME on that.
Great. Okay, that's what I wanted. Thank you.
No worries. All right, so we have the libraries loaded, and then let's take an example, which is an Excel file. Excel is ubiquitous, it's going to be here forever. It's immortal. No matter how much, anytime people say want to move things away from Excel, you still have clients that say, after you've given them a wonderful dashboard or a wonderful report, they say, can I have it in an Excel file? So for some reason, Excel is going to be here forever. And it's more often than not, Excel introduces issues in data one way or the other. One of the things about Excel is it keeps its computation close to the actual values, which can create problems. But let's take this as an example. So if you look at row 7, you can see null all through the row, which is useless. If you look at the column names, you have a question mark next to full-time, you have do not edit. Those are probably information that were written there by whoever created this to the next reader. But when you're doing your data analysis or your data wrangling, it is pretty much not helpful for you. So looking at this, we need to clean it up and make it useful. If you look at that column where it says certification, certification 1, certification 2, for some reason the person felt, let's create one column with certification. And if for some reason in the future somebody comes and they want to add in another information, let them create another certification 1, and then add another one. But when you're doing your data wrangling, again, just have one column that represents a variable, let a row represent an observation, and let each cell contain a single value. So let's see how we can clean this up. So the very first thing is This is a Pygenitor function, clean names. What it does is it converts all the column names to lower columns, and then if there are spaces in between the names, it replaces them with an underscore. The next part is to remove those empty rows. So remove empty rows, completely empty rows, and completely empty columns. You have the option of specifying if you want to remove just the rows or the columns, but the default is remove all empty rows, all empty columns. And then you can rename the column to something more sensible. And at this point, we move to this point where you coalesce the certification columns. Now, let me take it back a bit. Notice we have certification, physical ed, we have a none here, we have a none here, and we have a value here. So we want to move, if there's any null on the certification column, we want to move the certification one values into the certification column. And that is what coalesce does. It's sort of similar to what you have in SQL, and it moves the values over here. And then once you're done the coalesce, you can get rid of the extraneous column, which is certification one. And finally, you can convert the dates. Initially, they were in text. So Excel stores its dates as numbers. So with this, you can convert it into actual dates. There are other processes you can do over here. For this employee status, or even the first name and last name, you could probably convert them to categoricals. But this should give you an idea of what you can do with Pygenitor in a way. So you can stare at this and say, okay, it cleaned the names, it removed empty, it renamed the columns, it coalesced, and then it converted the dates to it converted an Excel date to a proper date. It gives you an idea. You can also do it via Pandas. So using the clean names, you can drop nulls on the rows, drop nulls on the columns, rename the columns, assign a new value, that's the coalescing here, you drop it, and then you assign the new dates here. This is Pandas. It works, it is effective, but again, the idea is if I'm coming back to look at this one compared to this one, of course I'm biased, I am a contributor to this library, so of course I would say the Pygenitor looks better. I just feel when you stare at it, you can say, oh, this makes more sense to me than this, but then that is my bias. And of course, every library has its bias. The other option is getting data from the web. The web is another place where you can get data. And one way, I'm not going to go too much on the nitty-gritty of what it is, but I'll take a sample of it. This particular column here, revenue breakdown, apart from the fact that you have information in the brackets that are not useful, within this particular cell, you have combinations of values. So you have book sale, $9.125 billion. You have box office, blah, blah, blah. You have some other retail sales. So you're having multiple values combined into a single cell. Again, for proper analysis, if you're going to do a data wrangling on this, you need each row to be an observation, and each cell should contain just one value. That's with this way you can do it. You can't really do any transformation or aggregation or get proper information from this. So the first thing to do is to wrangle it. So using Pandas, this is a Pandas function, set axis. You just replace the column names with something more sensible. You process the text. Now the process text is a Pygenitor function. You pass on the column name. It's a wrapper around, again, Pygenitor is nothing but more than wrappers around Pandas and NumPy. That's all it is. Pandas, NumPy, Python. So the first argument is the string name, is a column name, followed by the string function. So if you know Pandas series.string, if you know what the string function name is, pass it there, and then pass in the keyword arguments. So for this one, it's Pandas series.string to replace. You pass the keyword argument, which is parts. You pass the other keyword arguments, and then you pass the regex, which is also a keyword argument. Same for all of this. So basically, that's what process text does. Column name, and then the keyword arguments for the particular Pandas string function. So once we do the process text, we explode. Explode is a function in Pandas where you you probably have a list of values and then you want to break them into individual cells, which is what we did here. And then you have them all on their own. Further processing, and then you use your process text again to clean up. You separate these revenue items into individual columns. So you can see revenue category and revenue. You do a filter with the query function from Pandas. So you just want to keep the ones that have the billions or the millions in them. You move on to the next place and you use the replace function. It's an underrated function in Pandas, the replace function, because it does a whole lot of things. Well, essentially what we're doing here is passing a column name and then passing a series of regular expressions, more or less. So if there is a match for something that contains the box office, whether it starts, whether it's at the end, replace it with this. If the column contains DVD or Blue or VHS or home video, replace it with just this. That is what this replace function in Pandas does. And we come again and we do another series of process text where we get rid of the alien at the back. And then because the revenue could be billion or million, we'll find a way to just convert them into a single value. And the final part is where we convert that column to a numeric column. And then if you like, you can reset the index to just make it regular. And so what you have at the end is a franchise, your year created, your total revenue, revenue category, and all of that. Again, if you look at this, you can still do some more transformations. You could say you want a column for the middlelet. Middlelet has different subsections, so you could have one column for that and then subsections. You could do some more for the owners, maybe Warner Bros. As the parent body, Tolkien Estate as the sub-body. There are many ways to go with this. It's left to you, and that's where your subject matter expertise come into play. You know what you're working with. You adapt the tool to suit you. But again, looking at the code, you can say, oh, I set the axis, I process some text, I exploded it, I process some text again, I deconcatenate the column. My chemistry head sort of takes into this where you deconcatenate chemicals, you queried it, you processed again, you replaced something, you processed again, and then you reset you transform something to numeric, and then you reset again. Again, top to bottom, you can read it, it makes sense. If you come back maybe a couple of years or a couple of minutes from now, you can sort of make sense of it. That's the whole idea behind Pygenitor. Wrap functions or wrap repetitive things in functions that are easy to understand. Naming is not the easiest of things. As a developer, I guess we have an idea about that. But naming kids is hard, let alone naming things that other people use. So, well, having a name that you can understand and stare at and work with is really helpful. Now, let's just jump in and look at some functions. There are a lot of functions in Pygenitor, but these are some of the functions that appeal to me that I get to use quite often. And because I have a bias towards them in terms of the simplicity that they afford. The first one is the pivots function. So Pandas has the stack, it has the melt, it has the Pandas wide to long. They serve different purposes, but their ultimate goal is to transform a data from a wide format to a long format. We felt that we needed something that encapsulates all of that. Takes away that cognitive burden of you asking yourself, should I use a stack? Should I use a melt? Or should I use a wide to long? The pivot longer sort of wraps all of that for you. It doesn't cover everything, but 99% of the time, it should suit your use case. This example was adapted from our data table and the Pandas node function. Again, it's a wrapper around Pandas, nothing else. Pivot longer is a wrapper around Pandas melt and Pandas concats. As easy as that. We do some checks underneath, but that is all it is. So let's take these examples from Pandas melts. You have your data frame and we want to transform it. Sorry. Using pivot longer, we can flip it and just pass your index to it. Your first and last column, you get that. If you're a bit lazy, you can use the asterisk option and just say, I want only make the index, select the index for columns that end with ST. So it knows that you just want all of that, and then it will take care of that for you as your index. Let's say you want to pivot that, and then you want your dimension, and you want your values in meters. So your index will be columns that end in ST, which is first and last. You set your names to as the dimension, your values to as your values in meters. This idea is gotten from tidyr's pivot longer function. And you want to sort it by appearance. So if you notice the previous one, it was John, Mary, but you want it to be John, Mary, it's up to you. If you want to preserve the index, it's up to you. Again, it's just a wrapper around Pandas melts. Now, if you take it a bit further and you say there are multiple names in your columns and you want to separate them into individual forms. So you have sepal width, petal length, petal width. You just want them to be individual, maybe parts and dimension. This is one way of doing it in Pandas. You set your index, you split the column. The beauty of this is when you set expand to true, it converts it into a multi-index. You can then set your names, you stack it, and then you get this. With pivot longer, all you just need to do is pass it into it. So you know your names, so you want it to be parts and dimension, you know your name separator to be a dot, and it takes care of that for you. Again, you don't need to worry about the cognitive load of should I use a stack or should I use a melt. Give it to it, it will take care of it to abstract the dramas for you. Let's say you want to keep part of the column name as a header. This is Pandas white along, a powerful tool. Use this, and that is great. You want the sepal and the petal to be the column names, and then you want the dimensions to be on the side. Use this. If however you want the dimensions to be the header and the parts to be this, all you just have to do is do a reversal of the columns, position of the columns, and then you have your results. But with pivot longer, you don't need to worry yourself about this. You know that, okay, I want to keep a part of this as a column header. You use the dot value like a placeholder. It will tell pivot longer that this section of the column name should stay as a header. So in this case, dot value sepal will come as the header, and then the dimension comes as the length. The other way around, you want the parts to be in the column, and so you flip the position without you having to do the transformation yourself. Just say the parts and then the dot value, and then it takes care of the drama for you. Again, all encapsulated within one function. What if there's no defined separator? This is where the names pattern comes into play. The example is taken from our data table. We've been using name separator, but in this case, you can't use a name separator for this. So passing a regular expression, you want diagnosis, gender, and age. We have 3 groups within this names pattern, and that's what it works with. So you have one group, a second group, and a third group. And the function will know how to separate it and say diagnosis represents this one, gender is this, age is that, and it takes care of it for you. Again, abstract it for the user, and let's move on to something more interesting that is not data cleaning. So that is it for pivot longer. Another function that appeals to me is when you try to make or show missing rows. So maybe you have 1, 2, and 4, but you notice that there's a 3 missing. You want that 3 to appear for some reason. Probably you're doing a graph and you want to show that there's a missing value in there. I like to think of it as the inverse of the drop NA. So take, for example, this. In Pandas, you can achieve this with stack and unstack, and you can also achieve this with a reindex. So having a look at the first one, you set the index, you unstack, you stack, you reset. You have your index in this case, you generate your multi-index, use reindex, and then you have your results. With Pygenitor, we feel this name is borrowed from tidyr. We feel you just use the word complete. I want to complete this. Pass the columns you're interested in. Don't worry about the dramas underneath. Just pass the columns you're interested in and it gives it for you. Maybe you're interested in having it in a particular order. You want it to be, look at this, it's Anne and Bob, Anne and Bob. You want it in a particular lexicographical format, that's fine. And if you notice when we flip this, Anne is the first because Anne comes, A comes before B. So Anne, Bob, Bob, Bob. Whatever column starts controls a certain order. Again, pass the names of the columns you're interested in. you can pass as many columns as you want. Think of it as a variable argument. So date, name, and X, and it will generate all of them for you. If you notice, it's generating values that might not even be in the original data. What if you just want only data that is already existing? You don't want something that was not there before. Take, for instance, this, you have what, 3, you have a 1, you have a Bob, you have a 3. But in this case, when we combine this, you will notice that there isn't any 1. You have your 1, you have your 2, but there's no 3 and Bob in here. You're restricted to just what is in your data here, which is 1 on Bob, 2 on Bob, but there's no 3 on Bob because there was no 3 combination with Bob in the initial data. Again, what do you want to achieve? Let the function take care of the drama for you. You could pull this off with a stack, with an unstack, but that's a cognitive load for you compared to saying, hey, plug and play, fix it for me, and move on. What if I want the data expanded to 4? You could do this with a stats unstack. Complete says, all right, give me a dictionary. The key thing is that the name or the key of the dictionary must be a column that already exists. You can't give it any new column name. It must already exist in that data frame. And then it will do the rest of the drama for you. Let's say you want to fill in the values. Great. You can pass in a single value or you can pass in a dictionary and fill them individually. Again, try and abstract the process as much as possible. There is another function where if you have nulls already in your data and you don't want to fill the existing nulls, you want to leave them alone, you just want to fill only the newly created nulls, you have a function in complete, so you just say explicit is either false. If you say explicit is false, it won't fill any existing pre-existing nulls. If you say explicit is true, it will fill up everything. But again, if you have some time, have a look at the documentation, play with it. It's also performance. If you try it out and you see there are places where we can improve with the performance, please let us know. It's a learning process. No one knows it all, so please. Now, we've seen how stack and unstack can work. This has its limitations in the sense that if there are duplicates if there's a duplicate index, you can't use a stack unstack, you can't use a reindex. Index has to be unique. So let's say you have something like this. This is copied from Pandas documentation from pivots. If you do a set and unstack, it will tell you there are duplicate entries cannot reshape. If you use a reindex, it gives the same error. If you use a complete, it takes care of it for you. Now, you can solve that by just creating your data and then doing a merge, an outer join. But why worry yourself about the details when you can just do a plug in and play and just find something more interesting to do? And that is what complete does. Under the hood, complete finds an efficient way to generate all the data and then uses an outer join. That is all it does. Nothing fancy, but then it does the job. The last one, or the penultimate one, is the if-else function. There isn't any dedicated function like case one in SQL. This covers that for you. Again, this particular question could have been solved more efficiently with a pandas.cut. So you do a binning, but I'm just trying to use this as an illustration. So with the case one function, you pass in your conditions and your values. So this is my condition, this is my value, condition value. You can use one, you can use multiple. And then the last one is just a single value where default is false, and then you pass in your column name. You could also use a string. If that string can be evaluated with pd.eval, it will work. So age less than 10, 10 less than or equal to age less than or equal to 20. Basically, just passing it as strings and it will take care of that for you. So instead of you worrying about numpy select or numpy where, it does all of that for you. Under the hood is nothing more than pandas.series.where. So this is the last one, and this is one that appeals to me in the sense that as data engineers, you want to take advantage of speed wherever possible. And one of the most efficient parts is the command line. It's been around for like forever. It's been optimized. You have your sed, you have your grep, you have your awk. I'm no expert in when it comes to Unix tools. I still have to look at the man help to use them. But if it's there and it will make my job faster, I'll take advantage of it. One example is when you're reading data from reading data multiple data from a zip file. Pandas requires the zip file to just have one content. So if it has multiple content, it gives you an error message. So if you notice this, it has iris zipped, iris setosa, it has 4. But with your command line, this is nothing more than a wrapper around Python subprocess.run. So you just pass in your command line to it and you say, I want this particular file, and it gets it out for you. The other advantage of a command line is speed. Let's say I have a lot of data and I want to just get, this is about 2 million rows, which is a bit small, but you just want to get a specific amount. You don't need to get all the data. In Pandas, you're reading all the data first before you filter. With the command line, you can pre-filter before you dump it into Pandas. So take, for instance, this, you're reading the data and then you filter for California. Whereas with the Unix, you can, this is on a Mac, so I'm using a gggrep, but basically I can say, just look for California in the text and it filters it for me. Again, these are other options. You can use the XSV, which is a Rust implementation. You can use awk. I prefer mock since it's a bit faster than awk. And then when you look at the speeds, you can see, bear with me, my machine is not that fantastic, but you can see that the Pandas read takes about a second, whereas the other ones is about 130 milliseconds. This is a rip-grep RG. It's a very fast implementation of grep. And you can see it takes about 76 milliseconds. And the memory profiling, it's a bit less without the increments, which is, if you think about it, the larger your data, the less memory you want to consume so that your processes can be efficient. So again, Pygenitor is just a wrapper around Pandas functions, NumPy functions, and Python. Nothing spectacular about it. But again, as an engineer or as an analyst or someone who is working with data, you don't need fancy when you're dealing with data cleaning. You just want to get the job done and move on to the actual beautiful part, the parts that the client likes to see, which is beautiful dashboards or a machine learning algorithm that tells me I will make $1 million in the next 50 days if I keep playing 555, 666 at the Powerball. Again, make life simple and just focus on the details. Pygenitor has other submodules, biology, time series. So if you are interested in those submodules, maybe you have a specific field you're working and you want to delve into that, please feel free, visit the library. It's a wonderful library. I've learned a lot from there. I still learn a lot. So please come around, infrastructure-wise, comments, reviews, feedbacks, criticisms, please. It's, okay, not trying to sound political, but there's no need to be like YouTube and just leave the thumbs up button. You can come in there and say, look, this thing is not fine. Can we do it this way? Give us a thumbs down. When you give us a thumbs down, tell us why you feel it's a thumbs down and point us in the right direction so that we can make things better. That's the whole beauty, or that's the whole idea of open source, and that's why it's open in the first place. And thank you for listening to me rant. I shall pass it back to the host.
All right, thank you, Samuel. Are there any questions? Do you have any questions for Samuel?
I see one in the comments. Which Pygenitor's method saves the most space compared to the pure Pandas implementation? For example, a method that can replace 20 lines of Pandas code. And what is your favorite Pygenitor's method?
Pivot longer. Pivot longer will replace as much as 20 lines of Pandas code for you if you're transforming data. If you have some time, go on Stack Overflow, look at some questions that I've answered with pivot longer, and to give you an idea of what it can do.
And also, what is your favorite Pygenitor's method?
Well, yeah, that's my favorite Pygenitor method. Pivot longer.
How long has the project been running? Like, is it?
It's running for about 2019. So it started off in 2019. I think it was at SciPy or so. Eric Ma, I'm pretty sure some folks here would know him. Eric Ma started off the project with a couple of other members, and it's been interesting.
So where can you find it? Like on?
It's been horrible.
Is it on like on GitHub or someplace?
Yes, it's on GitHub. So if you just type Pygenitor GitHub, it pops up.
Awesome.
So
Eric Ma for mom, M-A.
Very powerful. I'm surprised because a lot of times I need to do things that are very much related to what you're showing. Especially the cleaning up of types. That this is Pandas is nice, but it's like everything eventually becomes an object. So if you want to type for a column and like someone puts in not a number with a column that has like numbers, and or someone puts in a piece of text that throws off Pandas completely. So only this is powerful. Now my question is, how does it do it? Does it do it at the level of like there's like a fast code that does this, or is it like Python code behind it? Because sometimes you can do those manipulations in Python, but they take forever. Like if you try to map columns and stuff like this, they just take like even concatenation of two columns takes forever sometimes. So what?
So Pygenitor is, again, Pandas. One of the ethos or motto of the library is make it easy for people to contribute to. So there was a time I was working on a code conditional join, where you can, instead of using your equals, you can use your less than and greater than. I wanted to dump it down into C, C++, but then it was advised, look, let's keep everything within the Pandas paradigm. Let's keep it as simple as possible to make people contribute. If we jump into C and C++, it makes it a bit harder for people to contribute. And I can say from experience with the Pygenitor table, it's built on C++, it's fast, but if you go to that library, you can tell the number of times people have contributed to that project. So as much as possible, we use Pandas. If we notice a speed issue, we dump down to NumPy. So take all the project, take everything you need to do and then dump it into NumPy. Take, for instance, I'm trying to think of, there's a function we have, expand grid. Expand grid is more like a Cartesian join for all intents and purposes. You can do that with your Pandas merge and passing across. If you look at it under the hood, Pandas merge is nothing more than df.assign t is equal to 1.merge, df2.assign t is equal to 1. So you're using the t equal to 1 as your join columns. Whereas if you dump down to NumPy, you use the mesh grid, which is what we use underneath the hood, you get a faster implementation, you preserve your D types. And another thing we do is we dump down into not using concatenation. There are some points where instead of using the Pandas concats, you can just build the data frame afresh without using copy. So making copy is equal to false, and you get a faster results. We use copy is equal to false in the Pandas data frame because at the outset of almost every function, you make sure that you make a copy of the initial data. So you do a df is equal to df the copy so that you do not affect the initial data. So you're overwriting it, the user can refer to his previous data, and then you can continue with your chain process. Again, dump it into NumPy, find a faster way. For strings, it's unavoidable at the moment because even Pandas strings are built on Python strings. So there's no way around it. And I'm not a smart person, not as smart as you think I am. I'm not as smart as I think I am. There are some smart folks out there who might be good with C and C++ who know how to write effective stringing in C. I give it to them. Maybe we can jump in on the work that PyArrow is doing, but at the moment, everything is reliant on Pandas and Python and NumPy. Even NumPy string functions built on Python in a sense.
So what you're doing, basically, you're trying to accelerate some things that people will do manually in Python. It will take them a lot of code and a lot of like inefficiently. You find ways to do it efficient by escaping to NumPy or using, okay. Yeah, that's a good answer.
But the first thing we do before we worry about the performance is just wrap it in the function. And then once we get it in a function that's understandable, then we drill deeper into the performance.
Okay. Very important what you're doing.
Totally. If I can jump, Samuel, this was awesome. First of all, kudos for reducing the cognitive load, okay?
Thank you.
That's huge. I have two questions. One of them, I'll start from the last one. In your examples, you showed chained assignments, chained execution. And, you know, sometimes when you do that as a developer, debugging that can be a little bit tough. How does it work on Pygenitor?
Yes, so that's why I wouldn't make it a hard and fast rule when you're using a chaining. For each, I wouldn't make it as a hard and fast rule when you're doing chaining. It depends on you. I think Tom made a position once that you shouldn't chain more than 5 or 6 lines, so that's easy for you to debug. It's one option. The other thing with Pygenitor is there are useful error messages. So if there is any of those functions that will trigger the error, it will tell you. The other part is, and that is going to be a bit of a cognitive load, which is what we try to avoid, is there is another library that sort of intercepts chaining. So if you put a decorator on top of it, it can tell you which line in your function triggered the error message. But again, if you are not comfortable, don't do too much. There's nothing set in stone. So if you feel, look, it's going too far, just write 5 chains, pause, start again, pause, start again.
This other library you mentioned, is it built into Pygenitor, like with decorators? No.
I wish I could remember his name. I know he's a fellow who is based in Israel. His name doesn't come to mind at the moment, but I will look for him and I'll put it in the chat.
Thanks. And the other one, I was curious about scalability of Pygenitor. You touched on that a little bit, and my impression is we're bound basically by Pandas and the hardware we're running.
Yes.
Yeah. Could you talk a little bit about how you're testing this package? Like, are you checking, like running it with like huge data sets?
Oh, okay. So our test is primarily on, and that is where we would welcome contributions. Our tests are primarily PyTests. So we write the functions and then we run the tests. And then, of course, we're limited by memory settings. We do minimal testing in terms of huge data sets. So I'll probably on my own, when I'm pushing a PR, I will take maybe Pandas. I'm doing, let's take for instance, expand breed. I will take a typical example, a typical scenario in Pandas merge.cross, run it, do a percent time it, and do that same comparison with a Pandas, with a Pygenitor expand breed and say, okay, look at the percent, look at the time difference. But again, as I think was the creator of Dask that said, always take testing speed with a pinch of salt.
Right.
Your hardware is different, settings are different. One of the things that would be welcome if anybody can contribute that is an ASV. So I know Pandas has this thing called ASV that can tell you if there's a speed regression or there's a performance improvement. So when a new function is introduced, you can tell that, okay, it has improved or it has decreased. ASV is such a function. So if we have someone that can come in and implement that for us, awesome. But most of our tests are basically PyTest and hypothesis. Hypothesis just so that we are not deceiving ourselves with fixed data types or data forms. We just use hypothesis, generate a million things for us, and then break it for us so that we can find the fixes and fix them.
Okay. Thanks a lot.
Thanks.
So I have a question for you, if you don't mind me jumping in. Could I ask you to pull up your slides again so we can look at one of the examples of the method chaining you're showing us?
Sure, give me a minute. Let me know once I get to it. Do you have any idea?
I wasn't thinking about one in particular. Yeah, just so we can see one of them. So like this one here, for example, this is perfect.
Yeah.
So you have dirty, which is just a regular Pandas data frame. We're not importing something different to make that something that's not a Pandas data frame. And we're calling all of these new methods that don't come with Pandas. Could you talk to us a little bit about how you are able to define your own custom cleaning methods and then make them accessible on that type of a class?
Oh, so, okay. Pygenitor primarily works on Pandas data frames. So the very first part is you need to convert whatever object it is into a data frame. There are some exceptions like expand grid that can work with lists or numpy arrays because it's basically a Cartesian output. But primarily it works with data frames. So it doesn't work with series, just data frames. Now, you can create your custom class with Pandas flavor, which is the wrapper that is used to create the decorator that does all of this meta chaining. And I probably would want to open the, if you have some time, you can have a look at the Pyjanitor dev homepage. I will type it in the group chat. There is a specific example there that shows you how you can create your own custom function and run with it. So if you have an idea of Pandas pipe, the way you write your dev function, and then you can then hook it into df.pipe and then whatever, that's a similar idea. But this time around, you will have your decorator at Pandas flavor, and then it takes care of all of that for you.
That's super cool. So the idea here is if I'm like somebody at the Austin Python meetup and I'm really interested in Pygenitor, and there is this like one particular cleaning method I need for, you know, whatever domain I work in, I can write my own little custom thing, put a decorator on top, and I can use it with Pygenitor along with all these other existing things.
Yep. Yeah, that's the whole idea.
Awesome.
Of course,
awesome. Thanks for answering that question for me.
It has to go through reviews and all of that. But yeah, that's it.
Cool.
Any other questions?
Can you help explain R and tidyverse methodologies and chaining versus Python's pandas with Pygenitor? This is confusing to me.
I'm laughing because you're about to go political, right? Well, anyway, it depends. I think Pandas is it's a one size fits all. What do you want? I'll give it to you. Do you want this? You want meta chaining? There you go. You want the block formats? I'll give it to you. Whereas tidyverse has an opinionated way of doing things. So it has to be, you have to use that pipe operator to be able to run from one point to the other. It has a functional approach to it. Pandas is, look, you want to clean your data, do whatever you want with it. I don't care how you want to do with it, just do it. And the funny thing is you'd expect that the Pandas way of doing things should not be popular. It is popular. It is funny that it is popular, but which goes to the idea that people don't really care. We just want to clean our data and move on. The problem is when you come back to that same thing you worked on 2 minutes ago, can you remember what you did? And that is where the tidyverse format comes into play. It's restrictive, it's fixed to a particular way, but it sort of helps you in the future to remember what you did. Say you want to move, it's a typical one. You have a column in dplyr or tidyverse, you have a relocate function. You want to relocate, as simple as that, you want to move this column from 1 to 4. There isn't a simple way to do that in Pandas. In dplyr, you can just do whatever function it is, relocate, move it to this position, whether you want it to be before this position or after this position, whether you want it to go to the last column. In dplyr, you have the reorder function, sort of. It's also, you can also use in the select, where you can just move these 2 columns to the front. So maybe A, B, and then everything. It's simple. It does the job. In Pandas, you have to do a bit more work on that. So they have their advantages. They have where they serve their purpose. I really can't come out here and tell you.
It has to be real. It's real specific. It has to be real specific for what the project's about. Thank you.
In a manner of speaking, yes. All right. I hope I didn't offend any R fans there.
No. David likes to ask questions. that are a little bit. You have to understand where he's coming from. It's all okay. He just has issues of, well, like, you have to show the alternative. So we're seeing one thing now. Switch to the other way.
So I'm just saying so because if you go into the R world, you
That's
have
it.
this eternal battle between data.table, and the tidyverse folks, and even the versus the base R folks. It's interesting when you read it on Twitter, which I have sort of left Twitter, but when you watch on Twitter, you can see the wars, and you're wondering, we just need the end result. Let's not worry about chaining or no chaining or anyway.
You're saying that it's like, it doesn't matter how you get there, as long as you get there, and you have tools to help get there.
Oh yeah. So when you look at data.table, now this is going to be a digression, but bear with me. When you look at data.table, it has a way of doing operations within the brackets, which is different from the tidyverse way of doing things with specific words and within a percentage. The percentage is your piping. So data.table doesn't believe in rehashing things that have been done. They believe, look, let's just keep everything as simple as possible within this bracket. If we can get everything to operate within this bracket, great. TidyR is, we're going to give you, sorry, not TidyR, tidyverse is we're going to give you a format that will make your processing clean in a chainable form, and you get your result. You can chain with your data.table, but as much as possible, data.table doesn't see the need to create new functions. If you have your lapply, use it. I'm guessing there's some R folks here that will probably know, I should correct me if I'm saying things wrong. In tidyverse, you have your pmap and some other functions that sort of replace your apply, your lapply to make things faster, to make your iteration a bit faster. Again, it's your choice. I'm not here to make it a do or die rule. I'm just saying these are the advantages you get when you use a method chaining format. Ali has already shown us the pending disadvantages of using the method chaining formats, especially when you go haywire and you just chain like forever, like it's never going to end. So nothing is set in stone, nothing is fixed. I'm not going to come here and sell to you that Pygenitor is the best thing in the world. It's great, it's fantastic, but it also has its limits.
Okay, I think you went into a lot of depths, but it's like you explained well this time. David, correct? You answered well now?
Yes. What I was hearing for that is format versus function with data frames. Yes, thank you for articulating that with Jacob as far as with alternatives, so we can get a better comprehension. Thank you.
Thank you.
Any more questions?
Yeah, this is fascinating.
Yeah,
This needs more than half an hour. We'll book you more. Don't worry.
Thank you for having me.
Well, thank you, Samuel. This was awesome talk. Thanks so much.